So just by way of review, as we are going to add and subtract rational expressions, we're going to take the exact ideas that we did back in 5th, 6th grade. Is that we're going to start, make sure you have like denominators. If you don't have them, you have to make them. Then we're going to add or subtract the numerators alone. That's it. The 18 stays 18 in the denominator. And this, of course, becomes 7 plus 3. Now, you don't have to write that. If you wanted to just multiply or add across, then you could have. But I'm just showing you all the work that's happening. And now we can reduce this one by 2 to get 5/9, and there is my answer. So these are the exact same concepts we're going to take, except we're going to be using things like x minus 5s or x plus 4s. So we'll make it more complex because life is more complex. And now when we combine these ones, we get 8 over 16, which gives me 1/2 as I reduce it. Always simplify at the end if possible. All right, so now let's take it here. Exactly the same thing where I just combine 5 plus x minus 5. So I'm going to write that out, even though some of you can do part of that in your head. All of that over 2x. One denominator, do not change the denominator. Don't say 4x here. Don't say 4x squared. Don't try to add or subtract or multiply or anything. Just write what you see. When they're exactly the same, boom. One denominator to rule them all. And in the darkness, bind them. Okay. Lord.
I got that.
Okay,
I thought somebody would say something.
Lord of the Rings there. Okay, notice here that 5 minus 5 is 0. Boom. You have $5, you spend $5, you have $0. So we're left with x over 2x, and now we can reduce the x's reduced to 1, and now we're left with 1/2. The most tempting part right here is to drop out the x's to reduce the x's, forget the 1, and people will write 2 as the answer. Do not do that. If you do, punch yourself in the neck. Notice where the 2 is. The 2 is in the denominator. It stays in the denominator. It doesn't magically float up without any other operation happening. Beware, whenever you have subtraction, this whole thing without parentheses is a group. Why? Because the vinculum here says that this whole thing is a group. So it has a hidden pair of parentheses there, so I have to distribute the negative across. So that's one possible first step to do. I'm going to write it out like so. 4 minus x minus 4. You did not have to write it out, but this is a fine thing to do. Next, we rewrote it, so we had one denominator, x plus 2, no changes there. And now we see anything that simplifies. 4 minus 4 is 0. So notice the negative remains. There is a negative right there. So I'm going to place that negative outside the fraction. Now, please explain to your neighbor, why do I not reduce further? Why do I not reduce further? So to answer that question, because of this plus, I cannot reduce further. So do not knock out these x's because there's a plus. The division and the addition are not inverses of each other. All right, now we can attack number 5 here and begin looking at things. Notice there's nothing to distribute, so I could just begin combining like terms. 1x plus 3x is 4x. The other like term is positive 2 and negative 2. Clearly those drop out to be 0. And the denominator is 2x. All right, so the mistake here, these need to stay the same. Do not make changes. That one's just x. I'm not reducing it. It was wrong. Now I can reduce. Notice I have 4 times x in the numerator and x in the denominator. So the x is reduced to 1. And my final answer is simply 4. I do not need to write the over 1 because that's how it simplifies. Bar number 6, we need to distribute that negative all the way across. So if I were to write it out, I would get x plus 2 minus 3x minus 2 because the negative goes here. Y también aquí. The denominator stays the same. Lo mismo. Do not need to. Now, if I could factor the denominator, I would start to factor now, which I will in the next problemo. Now I'm going to simplify where I can. Like terms here. X minus 3x is negative 2x. And then 2 minus 2, 0. The denominator does not factor because it is not a difference of 2 squares. It does not easily factor. Just notice nothing reduces here. So my final answer is this, of course.
That was a trick question.
It was a trick question.
I'm not good with this.
You're sneaking. All right, next one. Should I teach in Gollum voice the whole time?
Now, my precious Gollum, first we need to...
All right, we need to distribute here. Now, here's the magic. As I combine my fraction, what do I need to do to this denominator? I'm going to factor this puppy. And how am I going to do it? My sniggity snowflake. So I should have just made that a little bit bigger so I can just do that on the side here. So let me snowflakeify on the side there. Bink, 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 bink. I'm going to put a 3 times negative 2 in the numerator, or up in the top, a negative 6. Remember that the b goes on the bottom, and my wings are just the 3x's. 3x. Do not write the square. Now I find the factors of negative 6 that sum to negative 1, which will give me negative 3 and positive 2, like so. Notice that the left wing can reduce. I can divide by 3, so I get x over a negative 1. So what are my two factors? X minus 1 and 3x plus 2. So as I begin to distribute this negative here and combine my numerators, I'm going to go ahead and factor the denominator all in one go. So I get x minus 1 and 3x plus 2 factors down below in the denominator. Now I'm going to rewrite the numerator with the 4x, the minus x, and the plus 2. Great, and now we're going to simplify the numerator to get 3x plus 2 all over x minus 1 times 3x plus 2. Now I'm going to extend my fraction bar so it stays neat. And I notice something reduces. All the 3x plus 2's reduce, and the numerator becomes a 1. So my final answer is this, 1 over x minus 1. And there we go. So now let's look at the next problem here. Again, we notice that our denominators are exactly the same. So we are only going to add our numerators. So my next stage, and I'm actually going to do, well, I can do two things at once, but I will just bring these together like so and rewrite the trinomial there. Now, once I've done that, I am going to go ahead and start factoring. In the numerator, I can factor out a 2. GCF is 2, and I need to undo that because it has to be a 1. Now, I can do snowflake or some other trick here, such that 1 on the top, 2 on the bottom, x is on the sides, and 1 plus 1 gives you a 2. So my two factors are x plus 1 times x plus 1. And now the fun part where we start to reduce. The x plus 1's drop out. I'm left with a 2 in the numerator and an x plus 1 in the denominator, and there we have it. Again, something to notice is my denominators are the same, but I do have a negative that has to distribute to both of those. So While I combine like terms, I have a 2x minus x, so that's going to be a positive 1x. Here I have a negative 4 plus 7, which is going to give me a positive 3. Now down below, you may have noticed here that I have an x in both of those, so I can factor out an x using GCF. And now I begin the process of reduction to get 1 over x here. Again, to pay attention, do not knock out this x and this x, or this x and this x. It's the x plus 3 as a single unit needs to be reduced.